So we've talked about this before with other functions. Radical functions is no different. Whether you have a square root or a cube root in the parent function, these parameters a, h, and k are still the same. A parameter is still going to control that reflection. It's still going to control that stretching and compression. So remember, if A, the absolute value of A, because if it's negative or positive, it tells us if it's reflected. If that value is smaller than 1, it's compressed. If it is greater than 1, it is stretched. I told you look at the absolute value, because if A is negative, that's when it's reflected, or as you guys usually call it, flipped, going the other direction, that kind of thing. These things don't change with the different types of functions. Those values still do the same thing. So the h parameter still controls your horizontal shifts. H and H. So moves it left and right. So for these problems, the h parameter is actually going to control the domain. The k parameter controls your vertical shift, just like it always has. So that's going to be your up and down. And remember, the h parameter is kind of like the opposite value. I'm going to put that in quotations. So if it says minus h in the middle, or underneath that radical, say it says minus 3, you're probably thinking left, but it's really right 3. So the k parameter, since it's the vertical shift, controls your range. So we will look at actually graphing them. Before we practice graphing them, let's just practice looking at what their translation and the domain and range would be. So for the first one, 2 times the square root of x. The only thing that's happening here is that there is a 2 in the front. So 2 is larger than 1. So this is going to be stretched a little taller than the parent function. But other than that, it's not moving at all. It's not shifting. So really, it would still be starting from the origin. It's just that it's going to be a little taller. So if it's not shifting left or right at all, the domain, even though we don't have it in here, would be 0. So the domain is going to be from 0 to positive infinity. The range also. So let's do all the square root ones. So number 4, 5 times the square root of x plus 6. So the 5, larger than 5, is the stretch piece. And the plus 6 on the outside is the up. So up 6. So if you guys drew this on a graph, it would be up here. The first point would be up here at 6, and it would just be really tall, is all. But for the domain and range, again, there's nothing inside there. So we would do like plus 0 underneath that square root. So the domain is from 0 to positive infinity, and the range is going to be from 6 to positive infinity. From 6 upward would be your range. So number 5, the negative in the front means it's flipped or reflected. The plus 7 is left 7, and the down 2, or the minus 2, is down 2. So the first point, if you guys were graphing this, would be at -7, -2. And instead of going like this, if it's reflected, it's going to be going down. So what that means is for your domain, it's starting at that h value, that left 7, so -7 to the right. But the range, it's coming from the bottom and stopping at that -2 value. So the range is actually going to be from -infinity to -2. We're using brackets at the points because the points are included with the function. So the points, the data, like the ordered pair you guys start at, get the brackets. Infinities always get parentheses because you can never actually reach infinity. And then number 7, square root of x minus 3. So there's nothing in the front. There's no negative. There's no value. So it's not reflected. It's not stretched or compressed. But the -3 in the middle just means we're going right 3. That value is what controls your domain. So we would be right 3, not up or down any at all. So the domain's going to go from 3 to positive infinity. Range is going to go from 0. Because we don't want to write it, but that's the number on the outside. So let's look at the cube root functions. Now we said the cube root functions always have a domain and range of negative to positive infinity. So as soon as you guys see a cube root function, you might as well just write negative to positive infinity because that's going to be the domain and range every single time. So as soon as you see cube root, just put negative to positive infinity. You don't even have to figure it out. That's just what it's going to be. Now to figure out what the actual graph might look like, that's where we need to look at the translations or the shifts. So in this case, there's nothing being added on the inside, nothing on the outside. So the only thing here is the negative is going to flip it. And the 1/2 is smaller than 1, so it will be compressed. Number 6, this one actually also is compressed. 2/3 is smaller than 1. The +1 is going to be left 1. The +4 is going to be up 4. So what that means for you guys, if you were graphing it, like the normal parent function would look kind of like this. Well, this one, if it's moving left 1 and up 4, so left 1, up 4, it would just, the center would be up there instead of at the origin. So for cube root functions, you can always just put negative to positive infinity. That's what they will be every single time. For square root functions, the domain is based off the number on the inside of the radical, and the range is based off the number on the outside.